So thank you. Welcome to Andy Cheadle, close relative Don Cheadle, as far as I can tell, right? From McLaren. From McLaren Applied Technologies. So first of all, it must be a very inspiring place to go to work. But tell me, what is McLaren Applied Technologies? Because there's the entire McLaren group, and then there are people who drive cars, right? So where do you fit in there?
So just before I answer, I'm here to endorse everything that Vijay said, obviously. But one thing he said was that the car outside is about $1.3 million. It's actually only $230,000.
Discount.
Yeah, so I think they're sending a sales guy at lunchtime.
Yeah. The UCI discount. All right.
Look, because it's awesome. So Applied Technologies was really set up to help transfer technologies out of the Formula One race team into other market sectors. So we have 5 business units, motorsport, which is about 50% of the business and supplies into all the major motor series, as well as Formula One. And we supply all the Formula One teams with the centralized ECU that controls the car and the telemetry, and also the analytics platform for analyzing that telemetry. And then we've got a Automotive business unit that was originally set up, that we were set up to support in selling those engine control units into, and we help them with custom electronics for their cars. And then in healthcare, we have a business unit that is looking at human performance, so our heritage of optimizing the performance of the car, then optimizing the performance of the driver, so looking at biotelemetry, starting to help elite athletes better their performance. And then that's taken us into the clinical space with population health analytics, understanding how to help segment cohorts on a pathway for disease management. And then I've done healthcare, automotive, public transport business unit, which focuses on connectivity solutions for passenger Wi-Fi, seat sensing, looking at whether seat occupancy on a train fleet, and then connecting that to the billing systems and the booking system. And then finally, we have a business unit where we're in product development partnership with Deloitte, and that's really looking at transferring decision support, developing decision support products, which is capitalizing on our insight and strategy techniques from Formula One and bringing it into applications for like airspace control, planning, airport operations, and then manufacturing line optimization in supply chain.
So you told me you've become a product business, coming, inspired by the work that's happened.
So we started out as a technology consultancy, but we needed differentiation and scale rather than just adding heads to the business. That is in a similar way why we're in partnership with Deloitte. It's about unlocking revenues that scale beyond adding people. So products do that for you if you get it right. But obviously, recognizing, so part of our digital transformation has been, if you think about Formula One, it's a prototype series. And so you can make 80% of the progress in 20% of the time. But that, that final 20% is like 800% in terms of effort. And so recognizing the difference between prototype and production, as for software business, that's really important. And so we've had to do that at the same time as, moving from being very focused on low volume electronics supply and really recognizing the commoditization of electronics and adjusting the value proposition for the business to recognize software value and differentiate ourselves largely by, deploying solutions that go edge electronics up to analytical platform in the cloud. And that complexity of solution is what I hope differentiates us and enables us to compete and avoid being kind of brokered out.
So you mentioned digital transformation. Vijay and others have been studying that, documenting that, being able to communicate that. Tell us a little bit about what's happening in terms of digital transformation in the race space, and then how that carries over into your business. Because I think people are from different businesses here, and what are the things that you're learning?
So, if we wind back 50 years to some of that material you saw at the beginning, if a race engineer wanted to know how well the car was set up, he'd have to lean over the track wall and talk to the driver and say, how's that feeling? How's the car set up? How's the suspension? Where do you think we can get more performance? And then they'd tune the car and then go back out. But of course, now, today, we've recognized electronics for sensing, control. You put 300 sensors on a Formula One car, generates about 150 gig of data over a race weekend. 50 engineers at track are looking at that data for multiple applications, from condition-based monitoring of the components to performance optimization of the car to higher levels of race strategy. What is my pit stop strategy, etc. And then, in real time, you've got that data being sent back to about 70 engineers back at a factory who are running simulations to guide the strategy. So it's quite a big operation that's very data-driven, data-focused. And we've really, over that 50 years, been on a digital transformation from sensing, insight, adopting cutting-edge technology for competitive advantage, incremental improvement. You're having to compete every 2 weeks and come back with something more competitive. So you can't go away and do massive developments. You need to be looking at how to squeeze out competitive advantage every 2 weeks. And so that's taught us a lot about what you need to gain performance and how you apply technologies while respecting the regulations of the sport. And then within applied technologies, we take that learning and we translate it. And it's not just translating the technologies. We have done that and we do that, but we're also translating the know-how. So, everyone's talking about machine learning, about AI techniques, and we have quite a diverse, I call it a decision science group, because they're not just data science. They're stochastic machine learning, they're statistical, there's operations research and optimization, and then there's physics, simulation and modeling. And that technique, if you think about a Formula One car, it's the techniques used for understanding the car is basically a digital twin model. So you model the tires, you model the suspension strut and the forces through it using fundamental physics. You build up the chassis model, the engine model, to a total car model that combines all of those simulations. Okay, and that's a white box technique. Whereas machine learning, using Bayesian inference techniques of, I've got a data set, how does that data set train my model and inform my model to let me classify and recognize things in the future? So we bring a very different slant on kind of machine learning and digital twinning, because we're really fusing white box techniques of simulation and physics models with black box techniques of Bayesian inference. And that kind of hybridization is very much at the kind of forefront of academic work, let alone industrial application.
Gives you a gray box, if I have
It's a gray box. We call it a gray box.
I'm curious, right? You talked about that. You look, there's a new race every 2 weeks or so, and lots of people are talking about how can we increase the metabolic rate, the cycle time of what we're doing. You're forced to, right? The race will start in another 2 weeks. Clearly, there's a bunch of things that you're doing in technology, but what does it take in terms of having the organization be able to turn out a new set of, a new product almost within that time period?
So I think, it's interesting. The race team operate a command and control hierarchy, and they empower the people in their role to make the right decision. That sounds obvious, but it's not the most senior person on the pit wall who makes a strategy call. It could be, someone who's been working 4 years in as quite junior, but they're set up to make the call, make the decision, and everyone respects it. And that means that you've got to finely tune your team. And that kind of philosophy that has been, throughout McLaren's history is kind of what we translate as operational performance into our partnerships with Deloitte and the companies we work with. It's not just about deploying fantastic technology solutions. It's about, you can come up with a technology solution, and that isn't the problem. The adoption and the integration into the enterprise can be more troublesome than actually coming up with a technology solution.
So how do you do that quickly, though? I mean, you need to adjust the car, in a couple of weeks.
Yeah, so the team practice. They, as I said, they're respecting the organization and the hierarchy, and they train very hard. There's an awesome team. As you know, where the team are very public about how they're kind of reinventing themselves. It's quite interesting when you have to improve things every couple of weeks. You can start at X, not mean to end up at Y, but incrementally adjust until you do, and then you've got to reset. And actually, in this very technologically advanced sport, the reset can take time, but we're beginning to see the fruits of it.
So you mentioned these other businesses that you're in, which aren't even automotive related, right? Yeah. So talk a little bit about healthcare, right? I mean, I know we had a previous board member here, but how do you translate what we saw in the video to a wearable watch or what have you? Yeah.
So the journey's been quite interesting. I mean, as I said, MAT's been in healthcare about 7 years, and we started, literally based on looking at human performance and biotelemetry. So what are fatigue models, stress models, biomarkers for muscle wasting diseases, and we work with pharma on those. We worked on, wireless sensor augmentation for pediatric wards for cardio events, where you have. I don't know if you've ever been on a pediatric cardio ward, but it's very noisy. You get a lot of alarms going off all the time, and they're false positives that are, almost getting ignored, which is quite a problem, right? So we work with Birmingham Children's Hospital to put wireless sensors on these infants and babies. And of course, if you can wire up a baby and not have it, because they're the worst patient, right? They don't know why they're wired up, so they're like, chuck it off. Huh?
They're worse than F1 drivers? I don't know.
No comment, right? But that then, led us to work developing analytical solutions to help minimize the false positive rate. And then, that's taken us through the human performance, helping elite athletes to optimize them and their readiness to perform.
What does that mean?
Readiness to perform well.
What does it mean to help an elite athlete?
Yeah,
you could yell at them and try to faster, higher.
So nutritionally, how do you optimize nutrition? How do you optimize sleep cycles? How do you minimize fatigue, minimize stress?
You have sensors on these elite athletes?
Our heritage has been sensor deployment, collect high rate time series data. So these loggers are for high rate rather than the kind of low rate data that you see in many standard environments. And high rate allows you to spot anomalies in the data just sooner than you would otherwise, but also kind of features that you would never normally extract because they're missed in the low frequency elements. That led us to working with Lizzie Armitage, the bobsled team, and she did great a number of times. And we've worked through rugby, football, other sports.
And that original football, right?
The original football.
Not the one around here. Okay.
Not the one with the silly shape. And then really, that's taken us from human performance into mainstream healthcare. And there's kind of two propositions there. One is we're working on a wireless sensor device for patients recovering from total knee replacement. And that's really about helping the patient recover, right? The most optimum recovery program post-operation.
Is this a sensor in the knee replacement?
No, it's sensors worn outside, but trying to be minimally restrictive in the kind of contraption that you're putting on. So there's the sensor part, but then there's take the data, and then through simulation, through analytical machine learning techniques that I've described a minute ago, you're trying to refine the recovery program for that particular individual, rather than there's a sheet of 10 leg extensions, stand-ups, leg raises, etc. What does it mean to be personalised for you individually? And then into disease management, we're kind of carrying that forward to go from the person through anonymization, and there's a lot of talk about privacy of data, and we've all got to respect that, and we're all very careful to only work on anonymized data. But taking that up to a population level, it can help inform, again, the same kind of stratification for disease management through kind of care pathway optimization and refinement. So that's the journey we're on.
So let me pull this thread about people, right? So we talk about people, their health, whether elite athletes or patients. But you also have people that you employ, and particularly we know that talent can be a bottleneck to capturing value. And so talk to me about your competition for talent. Where are you based?
That beautiful headquarters you saw is based in Woking, which is kind of 10 miles outside of London.
But you said you also opened an office in London.
We had to open an office in London.
Had to?
So I opened an office in London when I had to make the pitch for it, to say, the only way we can compete with, the big tech companies is to offer a similar kind of employee value proposition. And that is...
You give them cars?
If they work hard.
Is there an employee discount? I mean, seriously.
If they stay long enough.
Okay.
So, part of the challenge is managing millennial Gen Z kind of work adjustments. That's work-life balance. That's impact to society. It's more than just remuneration, right? And it's also location. There's a whole number of factors that we've had to really learn and grapple with.
You're seriously competing with the tech giants for talent, right?
Absolutely.
Google or Facebook or whomever. So how the heck do you win that?
Yeah, so as I said, dragging people to Woking, even for that beautiful environment, is challenging. And so first thing, open an office in London. Next, show the value proposition through the types of applications we're working on. It is cutting edge technology. It is a lot of fun. It has massive potential in the marketplace to impact lives. And then I suppose, we're starting to have to look at the business models we use. A lot of people want share of value in what they're creating.
What does that mean?
Well, stock option shares, own part of what they create, and we're having to start to look at the kind of, we're privately owned, so we're having to start to look at the kind of business models that support those opportunities and attract talent. So it's quite a difficult landscape. I think, as an engineer, getting people, people come into an organisation And I say to them, what you're building today, you're kind of selling in a year and a half or 2 years' time. And so if you're only going to stick around for 2 years or 3 years, then you're not really going to get the experience of delivering end to end. And that's an increasing problem for engineering. People need to stay the course in what they're building and then get the delivery scars of it bedding down in the field.
And so how's it going on the talent front?
Very good. We have awesome teams.
Yeah.
But we're only 500 people, and we're not trying to create an army of McLarenites. We're really, focused on, I truly believe that you can do with a small number of talented people what, a team of 30 can't achieve. So actually, we have an awesome team and we're making great inroads. It's really good.
Two pizza box problem. All right, we have, if there are a couple questions, we'll just collect them and we'll let Andy answer. So there's a question here and then one up there. Okay.
Discipline it takes and some of the processes you guys use at McLaren to continually adapt and evolve?
All right, software and hardware integration. One second, let's collect the other one. Yeah.
So you had a lot of really transformative people.
So engineering digital products, engineering hardware. We're a low volume electronics manufacturer. A lot of people want to say, they're different processes. The two don't fit together. They don't work. We run a single development process. Our engineering teams are cross-functional, and we focus on kind of lean and sprint style agile methodologies, and then centralize the process around a coordinated backlog from product management to the engineering teams and the business managers. And once you do that, if you've got a process that you can optimize around the physical and digital, all you're really doing is respecting the different cadences of development. So a hardware program, okay, it's a bit more waterfally, you'll recognize the milestones, but that's no different to saying, well, that's sprint A, B, C. It's just on a different cadence to my 2-week sprint within a software environment. Does that answer your question?
It does.
Yeah.
Is it similar?
So innovation, I think, is the same through and through. It's just learn to be agile and fail fast. I think, we're always challenged with the ability to actually be really honest and say we're going to fail now and move on. We've learned all we need to from this and it's not going to work in the market. So we just adopt those kind of standard lean principles.
And then the next place?
Yeah, so from motorsport, I suppose we've transferred technology from motorsport. We're applying sensors to fleet condition monitoring in Singapore. We've transferred know-how from white box, black box machine learning into grey box modelling. I suppose the bit that we're kind of excited about at the moment is, all the motorsport series are challenged with how do I increase my reach, maximize my fan base, but actually move beyond your traditional petrol head to, fans, e-gamers, esports, etc. And for McLaren Applied Technologies, looking at what's been a traditionally B2B model and starting to look at how to get B2C with share of value transaction models through fan engagement development is, I suppose, the next exciting area that we're working on.
Thank you.
Grand Theft McLaren. Okay, we're between these good people and lunch, so I'm going to ask a very small set of very quick questions. Who's your favorite driver?
All of them. We supply all Formula One teams, so I'm just not going to pick
Of
one.
all of our children. Okay, what automotive feature would you most like to have?
Um, well, it's not politically correct, but we're kind of looking at motorsport series where autonomy is becoming it's a big thing, and so people are looking at autonomous vehicles racing, and there's a challenge to autonomous vehicles racing because you're not looking at the gladiator model anymore. So I've always thought it'd be good to have real missiles on the manned cars, laser tag on the autonomous vehicles, and then you can laser tag your manned cars, but you can blow up the autonomous vehicles. Am I allowed to say that? I'm not sure.
Max McLaren, speaking of autonomy, when will level 4 self-driving be available to consumers?
I'm not going to answer that. I mean,
it's fine, you can
it's
pass.
Massively challenging. I think, I'll sort of answer it. I mean, the technology is making leaps and bounds, right? But the legislation and the challenges around the safety cases in society, there's almost going to be, there's almost an admission that the safety of an autonomous vehicle has to be a much higher bar than for a human. And so until that's really well understood and we understand how to validate systems, deal with the pace of change, like you're releasing, new software to these embedded environments every 2 weeks. I mean, how do you control and validate that? So while the technology is there, we still need policy and legislation to really play out.
All right, when the regulators say yes. Okay, what type of sensor data is most underused?
Type of sensor data? Human? I mean, we're all generating heart rate, we're all generating many, many different insights, but how's that really playing through into public applications that are benefiting everyone?
From which company would you most like to poach their talent?
McLaren Racing?
All right. And what's the one piece of advice that you'd give to this group?
So I suppose, I've spent a lot of time working with chief data officers and obviously working on decision support systems in industry. And as I said, it's not the tech. You can come up with a decision support system to really impact the organization, but how do you actually embed it? So chief data officers, if you haven't got one, get one. And if you have one, give them a lot of love. They need support at the top from the CEO, and they also need support from the bottom to make sure that they can have a quick win in demonstrating value to the organization, and that what they're doing unlocks the data assets within the organization that can be politicized, etc. So love your CDO.
Please thank Andy.